Hey guys, finally decided to get to start working on Unity just for future game development projects that I'm planning at some point in the future. Yeah, basically, I know from what I've seen, it seems like it might be easier to learn this than the XNA framework or MonoGame framework. But yeah, let's get to it. So we'll turn this to this. There. It's not too loud. Decided to play some lo-fi beats. Alright, tutorial. In this tutorial, you will begin to explore the basics of Unity Editor as you playtest the beginning of the platformer microgame, review Unity Editor interface, make the player go faster. Ready, let's go. Alright, enter play mode. First, let's try the game using play mode. You can select play in the toolbar at the top of the Unity Editor. Okay, so this one. Deeper the scene view in the center of this layout is where you will manipulate and change things. When you enter play mode, the screen changes into the game view for testing. Okay. Ooh. Interesting. Interesting. Okay. Interesting. Alright, next let's make the player character move faster, go deeper. Everything in your game world, including the player character, is called a game object. Okay. The hierarchy is where you organize the game objects. Each one in your game is listed. It's listed there. Select the game object to find out more about it. When you select, okay, max speed property controls how fast the player moves forward. Go deeper. When you select a game object in the hierarchy, you'll see its components in the inspector. Components contain properties that give a game object specific functionalities. The player controller properties are what makes the player move in response to the player input. Increase max sprint. 10. Okay. So you would say like 10. Alright, let's test your change. Remember to save your change. In the top menu, go to File, Save. Alright, let's see how it goes. Ooh, much faster. Next steps. In the tutorial, you learn some basic Unity Editor interfacing, increase player keys. Next, you learn increase player speed and play testing. Next, you'll learn about more about the Unity Editor. Select tutorial 2, Editor Basics. Continue directly or done. Editor Basics. In this tutorial, you'll learn more about the Unity Editor as you change your view with the hand tool, move a game object with the move tool. Alright. Select the view tool. Alright, you can adjust your view so that it's easier to see what you're creating. The view tool lets you navigate your view of the scene. Alright, with the view tool selected, you can pan, zoom, or over on the scene view. Click and hold the scene view and move it. Interesting. Zoom. Zoom in and out. With the view tool selected, you can zoom in and out of the scene view. Hold down the Alt or Option key and the right mouse button, then move. Hold down the Alt or Option key and the right mouse button, then move the mouse to zoom in and out. Okay. Alright, using the move tool, let's move one of the collectible tokens. When you use the move tool, select any object. When you have many of the same game objects in one scene, it's easiest to select the game object directly in the scene view instead of the hierarchy. That makes sense, yeah. It's easy to select even. Within the scene view. In this tutorial, we're going to try to change your view. You're going to move game objects. Next, you'll find out how to change the colors of the game objects. Okay. Oh, yes. Make your game more colorful. You can easily change the colors of the game objects. Okay. Let's start by selecting the game object option. Before you can change the color of the player, you can easily get a better view of it. With your cursor on the scene, press F on your keyboard. Okay. You can easily get a better view of it. With your cursor over the scene view, press F on your keyboard to frame the player. Okay. In the inspector, let's change the color property to the sprite of the sprite render comparator. Okay. In the color wheel, use the slider to select a new color. Okay, now I'm confused. What? Did I miss something? Nope, no. Great. So is there another wheel that I'm missing? I see the color changing. So whatever this is, I can't go back. Did I bust something? Okay, that was weird. Okay, we'll go back to green. Alright. Try playing the game with a new color. Remember to save your changes. File save. Save it. In this tutorial, you learned how to change the color of a game object. Feel free to play around and change the colors of other game objects. When you're ready to continue, you'll add an enemy to increase the challenge. Then select tutorial file. Alright, tutorial. Alright, in this tutorial, you'll add an enemy prefab to make your game more challenging. So let's start again. Drag the prefab to the scene. Alright. First step of creating is add a new. The first step of creating an enemy is to add a new prefab. Let's add a hoverbot. Okay. Prefab are templates for game objects, preset components, and stored assets. You simply drag into the scene view. Select move in the tool, move tool. Select. Oh, wait, is the enemy where you want it to be? Okay, yeah. I think. There we go. Oops. Edit, undo, rotate. Edit, undo, rotate. Darn it. Undo, rotate. I think it's because I need to do this. There we go. Select to move tool. Do shortcut to use 0 to move in it. Next. Rotate. Woo. Ooh. It's huge. Use the rotate tool and scale tool to adjust your enemy. When you're done, hit continue. Okay. In the tutorial, you added an enemy prefab. Feel free to add more enemies for an even greater challenge. Next, you'll learn how to build and publish a project on a shareable web page. Okay. Let's see. Alright, before you publish your game, discover more ways to customize it with the platformer creative mods. When you're ready, this tutorial will guide you through building and publishing your game on a web page. Alright, so it's a whole different website. Okay. Open the WebGL publisher. In this tutorial, you'll export your micro game project as a WebGL game, and your game will then have its own dedicated web page. Publish WebGL project. Now that you've opened the WebGL publisher window, you can set up Unity Editor publish projects on Unity Play. Select Get Started in the WebGL publisher. Before you can publish your game, you need to build it. This will create a playable file of your game on your computer. This step could take up to 30 minutes. Huh? If you are prompted to switch to WebGL, click Switch to WebGL and choose a folder for your build in a window that appears. You can use the default folder or create a new folder to store your build files. Create a build, select a build and publish. Okay. Let's see. It did say it would take up to 30 minutes. Yeah. From the pipeline. I wonder if it'll take the full 30 minutes, though. Hello. Just got a encoder message. don't think I can do anything else while it's still going, right? Yeah. So I guess I'm stuck waiting for it. We're almost at the 10-minute mark. Oh, we're at the 10-minute mark. Good. Well, while we're waiting for that,
We're gonna upgrade our player from looking like this to look like this. first step is to go to Unity Assets Store, which is a marketplace where you can find 3D models, button, and it's going to import the asset files appear in your assets. I'm going to drag it into the sprites folder and rename it to just to keep everything organized. Now we finally get to replace our player with a better looking one.
Right. Upload completed. Okay. So you've almost ready to share. Before you do, add some details for your game directly when you play. Select done. Return to the tutorial overview. Okay. Is that it? I mean, I guess that works to a certain extent. Well, I guess I could then still at least play around with it. Yeah, at least I can still play around with it. Oop, I died. Ooh, got me. Oh. Ooh. Oh. Ah, I squished him like Mario. Interesting. Okay. What do the scripts look like? Fuzzy hit Q simulation. Enable play. Player stop jump. Player token collision. Player spawn. Oh, it's gonna open up this up in Visual Studio, really? Let me just pull this over. Alright, so we have of platform corner and place model. Execute. Look like it's true. Player's not dead. I wonder if there's a setting. Player done. I'll leave that here. Mode simple. Output priority non-physics. Body type. Go back to the previous one.
Hello and welcome to a brand new tutorial series where you'll learn how to make a 2D platformer even if you are a complete beginner. In these videos I want to focus on teaching you the basics of Unity while making a game that has movement, jumping, wall jumping and sliding, a shooting mechanic, multiple types of enemies and traps, a basic stat system and multiple levels. Keep in mind that what you see on the screen right now is just something that I made quickly in one day just to get the basics working. The final game will look much better and have a lot more features. So on this note we can start the video. The first step is to install Unity Hub, which is a program that allows you easily to manage all. And we're gonna go with 2D because we're making a 2D platform. You can switch back to the game view. Open the scripts folder first, right click, create, and C# script. We need to pick a name, so let's call it player movement. Now, in order to attach the script to the player object, we need to select the player and drag the player movement on it. Once you're done, you can double click the
drag player movement onto original. Non-physics material. Info. See, this is body kinematic, none material, none physics material, 2D. Controller. Oh, here's the script, player controller. Let me see here. Alright, this is the main class used to implement control of the player. It's a subset of the control class being aligned to allow for any kind of customization. Initial jump velocities at the start of a jump. Jump takeoff speed 7. Jump. Vector 2. Move. Sprite renderer. Internal animator. Awake. So when it starts the script, it pulls the health, the auto source, and the collider. And I guess it checks the object that it's tied to, in this case the player object. And then it runs the updates and it says, moved on X. Where's move? Yeah, vector 2 is X. If jump state, if you're on the ground, so basically the jump state says if you're on the ground and they press the button to jump, the button down is jump, then it says jump state, prepare to jump, and then else if you already jumped, stop jump if it's true. Jump state jumping, schedule, player, jumped. Compute velocity. So I guess this whole thing is the player control. So this one script that is tied to the player is the player controller, and this controls all of it. I'm guessing for the player controller script. See, this is player controller script just by itself. It has a script tied to it, but why doesn't this one? Maybe it doesn't have a script tied to it? I'm guessing it's this one, enemy control. Enemy controller. Oh, it's down here. I wish they would be in the same place, but yeah, it's right here. Enemy controller. Wake, on collision, enter 2D, move, let's create movement. Control path, move right bunch. So I guess you could actually set up an entire game with all of the objects that you want, and then start putting the code in that you would want after that point. If you wanted anything fancy. Is there anything else? Because whatever this tutorial is, I can't. See, this one comes there if I hit this one. This Microgame template is a classic tool you can mod and make your own. Check out the creative mods to change the project on your own. Okay. I just want the tutorial. Microgame change. Microgame. So is it a link? What's all this? Yeah, I thought I already did all this. So my first micro game. Use the tutorial. Feature tutorial should include. We already installed the hub. Did all that. Set up first micro game. Alright, install. After you complete complete the edit. I already did this. See, now I'm confused because I did all that under here, and then it says micro game mods. Try after you complete the in. Earning content no longer available. Okay. Right. I already know how to install Unity. In fact, I haven't installed already. So install Unity editor. Do that. You here for some establishing the entire pathway.
Welcome.
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 So I'm Mike LaFlame. I am one of the modelers at Cine Studios. I'm also a director of the company as well.
I'm Andrea Niceto, producer and partner and game engine artist at Cinecode, the virtual production arm of post-production house Digital Film Tree.
My name is David Whaley, and I'm an indie developer in Utah in the United States.
Hi, my name is Kira Benzing, and I'm a VR director, and I create interactive
Nah, that's fine. I just need to. You'll complete the tutorials for Unity and microgame. It's an interesting process and fun to process. Share a game on Unity Play. I've done all this. This is like they made me do it in the actual thing. All right, submit microgame gallery. Microgame reverse. So this is a tutorial. You will explore the windows in the Unity editor, understand the role of scenes, organizing a project, navigating the scenes, change view, enhancing these functionality packages. Okay. So before you get started with your microgame, let's take a look at the Unity editor. Okay, so well, now I'm confused. So well, see, now they've officially lost me. I have no idea, because I tried. Let me go back. Because see, it says this is what it is, but there's no start. Is this it? No, this just asks me to save anything, but I don't know. How do I load that in? Export the windows in the Unity editor. Okay. Overview. It says overview here. Before you get started with your micro game, let's take a moment to explore the Unity editor, its interface, how to navigate it, and some tips to help you get started creating. Okay, mark this complete. You'll have the micro game open for this tutorial. You will begin the editor tutorial until you're finished. For now, close the welcome dialog. How did you feel when you... Stop asking irrelevant stuff. How did you feel when the editor first loaded? So you established creative... Our established creative element for open... No, don't. Introduction to the Unity editor. The default Unity editor layout is organized with the most important windows you'll need positioned to help you complete the basic editor. Let's start by reviewing them. Well, that's not very helpful. Hierarchy window, project window, and inspector window, I think, and then scene. Consider the default Unity editor layout is the scene view. This is your interactive window into the world you are creating. You'll use the scene view to manipulate objects and view them from various angles. In the default layout, the game view also appears in this area. You'll use the game view to playtest your game. Hierarchy window. The hierarchy is where you can organize all the things in your game world and the world itself. These things are called game objects. If you add a game object to your project in scene view, it will be listed in the hierarchy. If you delete a game object from the scene, it will no longer be listed. What happens if you don't want all the objects to exist at once? The project window is where you can find all these files, assets available for use in your project, whether you use them or not. The project window works like a file explorer organized in folders. You can drag assets directly from the project window into the scene view to add them to the scene. Note the difference between the project and the hierarchy windows. The hierarchy contains all the game objects in the current scene, and the project window contains all the assets available in your entire project. The inspector window. The inspector is where you'll find and configure detailed information about game objects. When you select a game object in the scene view or in the hierarchy, you'll see its components in the inspector. Components describe the properties and behaviors of game objects. The toolbar is always at the top of the Unity editor interface. Use the toolbar buttons to select and adjust game objects, change your point of view in the scene, and start and stop play mode. Use the editor layouts. Use the editor layout. Use the layout menu in the toolbar to change the arrangement of the windows in the editor. Several layouts provided. You can save your own layouts. Best layout depends on what you're doing, your personal preferences. Okay. So using scene. Using scenes in your project. Projects in Unity are organized into scenes. Scenes are containers for everything in the experience you are creating. One way to think about a scene is as discrete experiences. For example, each level in a game could be a separate scene, and the game's main menu could be another. A Unity project can have one scene or more than 100, depending on its scope and complexity. There aren't strict rules about how you should organize a Unity project to scenes, except that the project in Unity must have at least one scene. Okay. Review scenes in microgame. Let's review the scenes in your microgame. In the project window, go to Assets, name of your game, and Scenes. Let me see here. Just move this over here too. Assets, name of your microgame, scenes. don't see it. I don't see. Oh yeah, you can add a new scene, okay. Well, that's not quite what it's supposed to say, but... Okay. Further... Showing all 3 menu scenes, for example, microgame sequence. Later, this path included 2 games. Scenes from scratch, okay. Navigating the scenes. When working in Peanut Editor, navigating the scene view is very important. One way to think about navigating is in this view, it's like operating a drone camera. It lets you examine your game objects from any angle or distance. In practice, you can learn to navigate with ease. There are also more general settings you can use to configure the scene view. Let's quickly review the basics. Pan the select hand tool in the bar, and click the drag in the scene view to move your view. Zoom. Holding Alt window. Orbit. Holding Alt Windows and left click and drag to orbit around so orbit. Holding Alt and left click and drag to orbit around the current pivot point. Note this option is not available in 2D mode. Okay, makes sense. Focus frame select when an object is selected. Fly-through mode. You can also use fly-through mode to navigate to the scene. Navigate in the scene view by flying around in first person, which is common in many games. To do this, click and hold the right mouse button. WSD to move. I wonder if it has to be. That's not moving at all. Okay. So maybe it's just for 3D. Fly-through mode is not available in 2D mode. They should have said that earlier. Instead, holding the right mouse button and pans the screen view. Okay. Introduction to Package Manager. Packages contain various enhanced Unity editor features that help you create a screen you want. There's some packages that are installed by default. You can also add packages to create a custom editor setup based on your exact needs. Features are packaged apart from the editor to reduce the initial element size and time required to install a Unity version. There's one package that might be helpful to you later on. Enforcement will show you how to install it. To review the package manager, you will use the package manager windows to install, remove, and update packages and add functionality to the Unity editor. To open the package manager, go to Window, Package Manager. Alright, packages contain various enhanced. Okay. By default, the window will show the Unity registry listing all the available packages you can use to enhance Unity editor. There are quite a lot of packages. Okay. Should you ever need specific information about a particular package, You can find each package's documentation in the Unity manual. Beyond the functionality provided by the core editor and packages you gain experience, you might need more custom tools to achieve your goal. This is possible through both third-party plugin integrations and by creating your own in-editor tools. Keep in mind, as you become more experienced, your possibilities are limitless. Packages in your project. Let's review the specific packages in your microgame project. In the left-hand corner of the window, select Package Scope drop-down menu and choose In Project. These are the additional packages that the team, which created the microgame, used to craft the player experience that you customized. Let's double check that you have the packages help to work with others and later in the course. Scroll the list in project packages and check if you have the WebGL Publisher package. If you do, skip the next step. Well, I already have that because I've already set that up earlier. Assets and Package Manager. We'll watch back to what that one guy was saying.
Player movement script so we can write some code. Every time I open a script, I prefer to delete everything I don't need inside it so I can get it to a clean state. This is just a personal preference, but you can do it if you like. Then we can actually start planning on how to properly move our player. You remember that we gave our player a rigid body 2D. Now we can use it in order to apply forces to make the player go left and right. In order to use the rigid body in code, we need to create a reference to it. This is why I created this variable of type rigid body 2D that has the name body. Now every time we're going to use the rigid body from our player component, we're going to type in body and call some functions. But this is only half of the work. Now we need to show our code where to take this body from. In this case, I will use an awake method. As you can see in the description right here, awake is called every time the script is loaded. So every time you start the game, the script is being loaded and the awake method is being executed.
What's the awake method for this?
On to the next part, which involves using the getComponent method. You can see that I typed here body equals getComponent rigid body 2D. But how does this exactly work and what does it do? Well, in this case, the player movement script is attached to the player object. And the getComponent method will check the player object for a component of type rigid body 2D. And it's going to find it right here, take it, and store it inside the body variable. So this is how getComponent works. Keep it in mind because it's one of the most widely used methods in Unity in order to get references. You can actually use it to get references not only to rigid bodies, but to all types of components like gliders, audio sources, etc. Our next step is to detect when the player presses left or right and move the body in the relevant direction. To achieve this, we're going to use the update method. Just like awake, update is a method that's pre-built in Unity, which means that Unity will run it automatically. But unlike the awake method, update does not run only when we load the script, but it does run in every frame of the game. Which is great in our case because we're trying to check when the player presses left or right. Imagine if we were trying to check for arrow inputs only when the game starts. In this case, you would basically press the left key, but the game would not do anything except on the first frame. This is why we need update here. It's going to make sure that on every frame of our game inputs are being recorded and the player is being moved accordingly. Alright, next up I will use body.velocity in order to directly change how fast our player body is moving and in which direction. As you can see here, in order to assign the velocity we need to use a vector, which is basically a collection of numbers because we need to assign the speed in all three directions, left and right, up and down, backwards and forwards. For the first coordinate, which is actually the left and right movement, I'm gonna use a property called input.getAxis. Then I'm gonna open the round parentheses and type in horizontal between quotation marks. To help you understand what this thing does, I made this sketch. So basically input.getAxis horizontal is a value defined by Unity. And every time you press the left button or the A key, it goes to -1. And every time you press the right button or the D key, it goes to 1. I like to use this value whenever I can because it helps me avoid if-else statements, which usually are a sign of bad code. Okay, this allows us to move left and right. To use this value whenever I can because it helps me avoid if-else statements, which usually are a sign of bad code. Okay, this allows us to move left and right. For the second and third variable, I'm going to use body.velocity.y and body.velocity.z, which just means that I don't want to change the body's velocity on the z-axis. Now when you go back into Unity, you're going to see a red error message below. This happened because of my mistake. The player's rigid body is 2D, which means its velocity is defined by vector 2, not 3. And it also means that we need to delete the body.velocity.z. Now when you go back into Unity, you will see that the error goes away, and when you actually press play, you can move the player square left and right. But you can also see that the player is moving at an abysmally slow speed. So let's fix that. Don't forget to exit play mode and go back into Visual Studio. To solve our problem, we're going to create a float variable that we're going to call speed, and we're going to multiply it with the input.getAxis horizontal. To make it easier to test and change the speed of a player, I want to make it
It moves a little slow, actually. No! Interesting. I mean, basically each scene has every object you'd want, and then at that point it just comes down to applying a script, but I guess the script is just controlling movement at that point, because everything else is already there. Like, script is controlling basically movement. You're not shooting anything, so all the entire player controller script is literally just there to control movement. Yeah, this entire script is just there to move the object around. Let's see. So you've got awake, update, jump state, compute velocity. Awake is just defining everything when it gets created. Then you update. Control enable. But I mean, basically, you could create the entire scene first before you do a lick of, before you even have a lick of code that you'd have to write a single script written. You could have the entire scene designed, have all the objects you want per each scene, and then go from there. Which, I mean, I guess that works in a way. I mean, I guess that means most of the scripting goes towards movement and AI control, I guess. Oh, wait, I didn't want to close that. Darn. Anyway. I'm curious as to when does the player spawn get called is what I want to know. This is public override execute. Player spawn simulation.event. Namespace platformer.kingplay. Simulation events you do. Player enemy collision. So this is the when they collide. See, because this is player control kinematic object. Compute velocity. So we already know that this is tied directly to the player. So this script gets called. Is there a way to see what script is tied to what object? Yes. Cinema machine confirmed. That does spawn. Main UI control. What is this? Okay. So it switches between UI companion. Event system. Tile map collaborative. Did that have all that? Audio clips. Oh, so it defines a bunch of audio clips, which you can then probably just drag to those spots. Huh. Energy volume. Like, I see the scripts here, and I know what they are supposed to do, but I don't know how they're tied to the object, so... I wonder if I could... Open Singular's Edge. Find controller script. Oh, okay. So... Right. That didn't find anything. Yeah, because if I go to mechanics and then go controller and then find references in scene, yeah, this object is the one that references it. Find references in scene. Yeah, see? See, if I tell it find references, find references in scene. Yeah, you can tell they're being referenced by which objects. But then if I were to go up to like gameplay and like do player death, find reference in scene, the entire thing's blacked out. There's no reference to the player death, so how does it know that it's using? Fired when jump. But then how does it get triggered? It's, you say it's scripts, core, gameplay, mechanics. I wonder, is that true for all? Do all of them have this set? Well, so this says simulation platform.model. Platformer.model, platformer.core. So he uses these, it references them. Player controller. So this gets called core mechanics and model. Event platformer model simulation model. Override void execute var model.player public override void execute. Platformer model equals simulation. Platform. Asset script model. This is platformer model. So platformer model equals simulation.get model, platformer model. And then it just executes that. Player stop jump. So it's not too tied to a specific object, but it still gets executed. Public class player stop jump simulation event. This makes sense. Platformer. Platformer.core, platformer.mechanics, platformer.core.simulation, platformer.gameplay, simulation. What is the event system though? I need more information about that. Event script or event trigger. Receives events from the system. Event trigger can be used to specify functions you wish to call for each event system event. You can assign multiple functions to a single event whenever event trigger is used. So none of them talk about that. Shooting. Red event. See this time.
Events are specialized delegates that are useful for when you want to alert other classes that something has happened. In practice, you will see that events function very similarly to multicast delegates. For more information on delegates, see the lesson on delegates linked below. An event can be thought of like a broadcast system. Any class that is interested in an event can subscribe methods to it. When that specific situation occurs, like a button click, a power-up, or player injury, we invoke our event, and that in turn calls the methods of the subscribed classes. We have here a scene with two orbs in it. One orb has a script called Teleport Script, while the other has a script called Turn Color Script. Attached to our camera is an Event Manager script. An event can be made for just about any situation.
An event manager script. Okay.
In this example, we want to invoke an event whenever the player clicks a button that we are drawing to the screen. In our Event Manager, we can see that we first create a delegate type, which we name ClickAction. We can see that any method that wishes to subscribe to our event must take no parameters and have a return type of void. Next, we create our event variable. We do this with the event keyword. Note that this variable is also static, so that we can use it outside of the class without instantiating an object of this class. Our event variable, which we have named onClicked, is of the type of the delegate we created above. The only other thing this class is responsible for is calling the event whenever the appropriate situation arises. Like we stated before, we will call this event whenever the player clicks our button. Therefore, this script has an onGUI method. Inside the onGUI method, we create a button on our screen. When the player clicks the button, we use our event variable as if it was a function. This, in effect, invokes our event. Please note that just like delegates, it causes an error if we invoke an event with no subscribers. Therefore, we should always make sure that the event does not equal null before invoking it. If you recall, the two orbs in our scene have two different scripts attached to them. These two scripts will act as subscribers to this event. Let's take a look at them now. In the teleport script, we have created a method called teleport. This is the method that we will be subscribing to the event that we created in the Event Manager.
I wonder. Yeah. Event player. Simulation.event player death. Class player spawn. Partial class.
You will notice that the teleport method takes no parameters and has a return type of void, just like our delegate. The teleport method is responsible for positioning the object randomly along the y-axis. Near the top of our script, we have a method named onEnable. This is a built-in method that will be called whenever the object that the script is attached to is created or enabled in a scene. We will use this method to subscribe our teleport method to the onClicked event of the event script. We can see that we subscribe a method to an event by using the += operator. By subscribing a method to an event, we ensure that whenever the event occurs, our method will be called. Next, we have the onDisable method. Opposite of the onEnable method, the onDisable method is called whenever an object is disabled or destroyed in a scene. Inside the onDisable method, we are unsubscribing our method from the event. We unsubscribe a method from an event using the -= operator. Doing so will ensure that our method is no longer called when an event occurs. This step is incredibly important, and failure to do so can lead to memory leaks and errors in your game. A good
Well, I think I'm going to call it there for now. We've had a good run. It's been pretty good. I'll have to go into more detail to see if what more I can learn. But this mini game has been a pretty good way of insightful way of learning the basics of Unity. At some point, like I said, I am planning on developing my own game out of Unity as opposed to Visual Studio,